Let's do constant acceleration worksheet problem number 9 from worksheet number 4. Here's the problem. It says a rocket accelerates at a rate of 20 meters per second squared. How much time will it take to increase its velocity from rest to 100 meters per second? How far will it go during this acceleration? Draw velocity versus time graph. So, given, we've got a rocket. Here's the launch pad. And it's blasting off. And while its initial velocity is 0, but it's accelerating up at a rate of 20 meters per second every second. That's pretty good. And then it's going to go from rest, so the initial velocity to 100 meters. So here it is way up here in the sky, this rocket. And its final velocity is 100 meters per second. And so what are we trying to find? A, how much time will it take to get here? B, how far will it go during this acceleration? Now, hey, usually when it's vertical like this, instead of calling it delta x, you can call it delta y. That's what I'm going to do. I'm going to call it delta y. Oh, wait a minute. That's the same thing. If you want to call it delta x, you won't offend me. Now, and then for part C, we want a velocity versus time graph. Let's solve over here. Leave myself enough room. Well, okay, here's what I know. Or here's what I want. I want time, and I know the initial velocity, I know the acceleration, and I know the final velocity. What do I not know and not need yet? Delta x or delta y. So I use the one that doesn't have it, so I'm just going to use the first kinematic equation. But now I'm going to solve it for time. Now I'm going to do this in one algebra step. V, subtract V naught from the other side, and then to solve for time I divide by the acceleration. You see how I did that? In one swell foop? All right. Yeah, never mind. So the final velocity is 100 meters per second, but our initial velocity was 0. That means our delta V was 100 meters per second. And we were accelerating 20 meters per second every second. So when I do this, this is 100 divided by 20. That's easy. No calculator needed. The meters per second cancel, and I get 1 over seconds. Reciprocate and multiply, you get seconds. So the time it takes to fly to this height up here, or to get to this final speed anyway, is 5 seconds. Part B, we want to know delta y. Well, let's say I don't know the time, because I don't want to carry this mistake forward. So I'll say if I don't know the time, and I already solved for it, but I don't need it. Hopefully I don't need it if I use the fourth kinematic equation. Now when you're working these problems, have your little equation sheet there so that these equations are handy. I haven't memorized. I should have them memorized, right? Okay, I've been teaching physics for a quarter of a century. I have them memorized. You should have when you're doing your homework, have your little cheat sheet or your little formula sheet there with you. Now, this is 0. And what am I solving for? delta x, or oh, I called it delta y over here. Doesn't matter. I'll just keep, I should just use delta x. So this is going to be v squared divided by 2 times a. Does that make sense to everybody, that little algebra step? Okay, if not, you need to go back and review some math. What is the final velocity? 100 meters per second. What do I need to do to it? Square it. Hey, very common mistake. Students forget to square stuff a lot. So don't forget to square. 2 times, what's the acceleration? 20 meters per second squared. Delta x equals, well, what's 100 squared is, watch this, I'll just write it out. 1, 2, 3, 4. 10,000 meters squared per second squared divided by 2 times 20 meters per second squared. Now, why did I do this? Just to make things a little bit easier, I guess. No, it didn't really make it easier. I'll just make this 40. It all depends on, I just don't want to have to use it. Oh, well, hey, look, that 0 cancels out. And how many times does 4 go into 1,000? 250 times, right. And then we've got a second squared cancels the second squared, and a meter cancels with the meter squared. And look, I'm left with a meter, and that's exactly what delta x is measured in, meters. So the units work. That means I probably did it right. So this rocket is 250 meters up. Now, we've got to do part C. Velocity is a function of time. We now know the time, 5 seconds. 1, 2, 3, 4, 5. Time in seconds. Now, what was the velocity? Well, the final velocity was 100 meters per second. Actually, that was given, wasn't it? So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Velocity in meters per second. I've labeled it. Starts here. And guess what that slope is? That slope is going to be 20 meters per second every second. And guess what this area is going to be here? It's going to be 250 meters. Watch. 1/2 the base times the height. What is 100 meters per second times 5 seconds? That would be 500 meters, but cut it in half because it's a rectangle. You get 250 meters, just like we predicted using the kinematic equations. This stuff really works, people. Any questions? That is all. How was my day? Go away.